Hi guys. So this one is actually, this is page 569, number 12. You can see that there's three rational expressions being added and subtracted here. This is going to get big. I'll help you get started, but then I want you to check the answer key to see what you can see there, okay? As usual, we always start by factoring the numerators and denominators. So we've got x squared plus 5x plus 6. If you were to factor that, that's going to be x plus 2, x plus 3. Now, this one right here, we can see that it's written backwards here. And from what we've seen in the past, that if I want to rearrange these terms to x squared minus 4, I'll end up changing the sign from positive to negative. Now 2 plus x, that can be rearranged really easily. 2 plus 3 is the same as 3 plus 2. So 2 plus x is the same as x plus 2. Now we can factor this denominator as well. X plus 2, x minus 2. All right, put brackets around the top. Now that's not the same here. 2 minus x is not the same as x minus 2. So it's like we're taking out a factor of -1 up here. And we end up with -1 x minus 2. And adding a negative, change that to subtraction there. And when we factor the denominator here, I think we end up with x plus 3. X minus 2. So we've straightened it out a bit. We've rearranged the signs a bit, something more familiar. Can any of these be simplified at this point though? Oh, hold on. Hey, we have an x plus, oh, let's get our non-permissibles first. X cannot equal, from here, -2, -3, or +2. Those are our non-permissibles. But we can simplify some of these first. Hey, x plus 2 over x plus 2, they cancel out. All that leaves us with is 1 over x plus 3. Addition sign. And over, oh wait a second, we got an x plus 2 in the top and the bottom here. Just leaves us with 1 over x minus 2. Subtraction sign. And likewise, oh, we got an x minus 2 in the top and the bottom here. We can cancel that out. Just leaves us with 1 over x plus 3. Now, if I give you this, 1 over 3 plus 1 over 2 minus 1 over 3, what would that work out to? Hey, 1 over 3 minus 1 over 3, they cancel each other out. All that leaves us with is 1/2. Well, it's the same idea here. We have a 1 over x plus 3 plus 1 over x plus 2 minus 1 over x plus 3. These two will cancel each other out. Just leaves you with 1 over x minus 2. That's it. Okay, so here's another one. This is page 569. This is number 13A. 13A. It's a combination. We're putting these together. We've got some addition going on, and we've got some division going on. So how do we approach this? Well, always start by factoring. Factoring your numerators, factoring your denominators. So if we factor, these are factored, 3x is factored. This can be factored to, we can take a common factor of 2 out. And we end up with 2 times x plus 4. And here we can take a common factor of 3 out. 3 times x plus 4. We find our we find our non-permissible values for now. Now that everything's factored, we find our non-permissibles. X cannot equal, from this bracket, -3. If I put -3 in x, I'm going to end up with a 0 in the denominator. Or -4. And from this one, -4 as well. What do you do first in BEDMAS? Do you do the addition first? So there's three rational expressions. Will we do the addition first or we do the division first? BEDMAS says we do division first. Okay, so division, how do you divide fractions? Remember, flip the second one and change it to multiplication. So when we flip this, we got 3 times x plus 4 in the top and x squared in the bottom, and we'll change it to multiplication. Hey, wait a second, we got a new denominator. That means we have a new non-permissible value as well. I can't put 0 into x as well. That's one of our non-permissibles. We'll do the multiplication first, and then we'll take the result, and then we'll do the addition. Okay, anything. Let's just look at these two right now. Anything common top and bottom? Yeah, I can take an x plus 4 at the top and out of the bottom here. And I can take an x out of the top here and one of the x's out of the bottom here. And all that leaves me with is I have the 2x over x plus 3 plus, all I have, now I have in the top, 3 times 3, that's 9 over 2 times x, that's 2x. Now, we'll simplify. We'll add the result. LCD, the lowest common denominator between these two terms is 2x times x plus 3. 2x times x plus 3. You can put it on pause, and you can finish this up if you like. And then compare it to my answer. Okay. Lowest common denominator. So we'll set it up. Lowest common denominator. Each expression expressed with the LCD in the denominator. 2x times x plus 3 and 2x times x plus 3. We still have the 2x in the top here. We still have the 9. But what did I have to multiply to top and bottom to get an equivalent expression? What's missing from here that we have down here? The 2x. So we'll multiply 2x over 2x. 2x times x plus 3, here it is. What's 2x times 2x? 4x squared. And then what's missing from here that I have down here? The x plus 3. So we're going to multiply top and bottom by x plus 3. So we end up with 9 times x plus 3. We got a common denominator now. So let's add the numerators over one of the denominators. 4x squared plus 9 times x plus 3 all over 2x times x plus 3. Expand. 4x squared plus 9 times x, that's 9x. 9 times 3, that's 27, all over 2x times x plus 3. If you can, factor the numerator and cancel out any common factors in top and bottom. I don't think you can go any further than that. I don't think I made any errors in here, but check the answer key. Once again, this was page 569, number 13A. And what we were focusing on was a combination that there was addition and division. You follow the rules of BEDMAS. Do the multiplication division first, and then do the addition and subtraction.